Hey, let's discuss the last part of the lecture. Recall that we want to solve the following equation. an yn derivative an minus 1 yn minus 1 derivative plus so on plus a1 y prime plus a0 y equals 0. This equation is homogeneous equation with constant coefficients, and we know how to solve it. We just write out the characteristic equation, which is an Rn plus an minus 1 Rn minus 1 plus so on plus a1r plus a0 equals 0. And if this equation has all distinct roots, the previous theorem tells us exactly the general solution. However, in practice, it may have repeated root, and the next theorem tells us what to do. So now if the characteristic equation has a repeated root r with multiplicity k, then the part of the general solution corresponding to this root r is c1 plus c2x plus so on ck x to power k minus 1, and then multiply with e to the x. Let's look at an example. We want to solve the equation 9 times y, the fifth derivative, minus 6y fourth derivative plus y third derivative equals 0. And the characteristic equation is just 9 r power 5 minus 6 r power 4 plus r power 3 equals 0. We can factorize it. R power 3 9r squared minus 6r plus 1 equals 0, which is r3 and 3r minus 1 squared equals 0. And solving this equation, we have two roots, y r equal to 0 with the multiplicity k equals 3, and second one r equal to 1/3 with the multiplicity k equal to 2. Okay, so now the part of the general solution corresponding to r equal to 0, k equal to 3 is just c1 plus c2x plus c3x square multiply er1x, and because er1x, let's use r1 and r2 over here, so correspond to r1, er1x just equal to c1 c2x and c3x squared, because r1 equals 0. Okay, and now part of the general solution corresponding to R2, which is 1/3, and K equal to 2, is just C. We already use C1, C2, C3. So in order to avoid the confusion, we have to use different notation for C. And we can start from C4, for example, C4 plus C5x, and e to the R2x, which is C4 plus C5x, and then this is e 1/3 of x, right? Okay, and you can expand them out. C4 e 1/3 of x plus C5x 1/3 of x, right? Then the general solution is the combination of all parts. Okay, so you have two parts of the solution. One is the one that's contributed by R1, and the another one is contributed by R2. We just combine them together, and you have y would be equal C1 plus C2 x plus C3 x squared, and then C4 e 1/3 of x, and then C5 x e 1/3 of x, and this is the general solution of the equation.